Hi, so in this video we'll be looking at the relative atomic mass part of the Unit 1 specification. So first bit, simple no statement within it. Basically for this it's just wanting you to be able to recall the definition. So the definition of relative atomic mass being the mean mass of an atom on a scale where carbon-12 has a mass of where 1/12, my bad, 1/12 of carbon-12 has a mass of 1. So you can replace that for obviously relative molecular mass, just replace atom with molecule within there. Now this little bit here is very niche. I've never seen this assessed on the exams. It's more or less just some science given to you in class. Because when you're working out relative atomic mass, the relative bit is what comes into play here. Essentially, you are always comparing everything to this carbon-12. So when you're doing so atomic mass does have a unit, it's a unit in Daltons, but when you're doing the atomic mass of the chemical that you're looking at, compared to the atomic mass of carbon-12, so you're doing one divided by the other, those atomic mass units cancel out, and therefore the relative atomic mass has no actual unit. That bit I would say don't worry about, as long as you can just recall that no unit for relative atomic mass. I think that's all it would ever ask of you. Maybe a multiple choice, what is the unit? Just tick no unit, done. So this little bit here is obviously the key part of this relative atomic mass section. I just want you to be able to calculate it. So relative atomic mass, what you'll be given is the percentage and of some isotopes. So we'll say, for example, chlorine 37 and chlorine 35. And we'll say I've got 25% of the 37 and 75% of the chlorine 35. Now to work this out, you simply do the percentage times the atomic mass that you're given, and you add them all up for each one. You might be given 3 at times for some of them, so it'd just be a case of adding a third one on there, and then divide by 100. Now you can simplify it a little bit. If you converted that percentage to a fraction, just did 0.25, and you wouldn't need this divide by 100 at the bottom, but I'll keep it in just for the sake of I've already written it. So 25 times 37 plus 75 times 35 and divide by 100. This may look familiar to you if you remember a little bit of GCSE maths. Essentially, it's just an average calculation. You're working out the mean. It's like saying 25 people weigh this much, 75 people weigh this much. So what does the average person weigh? And as you can see, that's basically how we are working it out here. So if we hit all of that into a calculator, what you'll get is the 35.5. Then as you can see on your periodic table, that top number there, not the bottom one, so the top number is the relative atomic mass of chlorine. So atomic number down the bottom, relative atomic mass. I have seen some periodic tables that have these the other way around. So just remember the atomic mass is always the bigger number because it's the protons and neutrons added together. Obviously there's decimal in this case just because it's an average. Some of them, as we can see, have got more neutrons than others. Okay.